All right, so here we go with the 4.3 key. I don't think we got to this one, so I'm going to go ahead and do this proof here. Okay, so basically we're given that AD bisects BE, so that could be my first step. So I'm just going to say AD bisects BE. So we know that if this line is bisecting this line, then BE is being cut in half. So BE is being cut in half by AD. So we can say that BC and CE are congruent. So that's my next step, right? Because of this first step, I can say that BC is congruent to CE, right? In other words, it cut BE in half. And of course, 1 was given, and I should have written that in there. And now we have 2. That's just the definition of sort of we'll call it a segment bisector. And now actually, we all also know that in this first step, I could actually say, oops, this should be 80. We also know that BE bisects AD. And so BE is actually being bisected, but it's also bisecting AD, which means we're cutting those in half. Right, so on the same step, because of the same reason, I'm just going to, right, I just put comma there, and I'll just put comma here, because it's the same reason, right? It's bisecting. It's a segment bisector. So I could say that AC is going to be congruent to CD. Again, that's just, you could put them in separate steps if you want. I just put them in the same step because, there we go, to make it a little simpler. Okay, a little more straightforward. All right, we're given that, I'm just going to put the other 2 segments in here. So we're also given that AB is going to be congruent to DE. And then if I hadn't had that marked, I would mark it. Also, we could say sort of angle A is congruent to angle D. And again, those are given steps as well. I sort of chose these. I could do something with them. These are just given. They're on the diagram. They're already marked. Okay. So a couple ways to sort of go from here, but the main thing is now I'm trying to prove these triangles are congruent. So to do that, I need all 6 parts at this point, right? So I need all 3 sides, which I have, right? These are corresponding, these are corresponding, these are corresponding. Got all the sides. Now I gotta need the angles, where I have these angles, and now I look and say, oh yeah, these are vertical angles. So I just got to describe why those are congruent, or I describe that they are congruent. So I could say angle BCA, right? So BCA is one of those vertical angles, and it's congruent to, let's say, ECD. And again, the reason is because vertical angles are congruent, which is this. So, vertical angles are congruent. Awesome. And then we can say, well, step 5 is, so we have 2 angles in the triangle are congruent to these corresponding angles are congruent. So we can say that the third remaining angles are congruent, right? And so if I say angle B, and there's only one angle B, so I can use it, is congruent to angle E, that's just because of that theorem, the third angles theorem. And so now we actually at the step where if I sort of keep track, I can say, look, we have a side. Oh, let's do all the sides first, right? So we have one set of sides here, another set of sides here, and the third set of sides right there. And then we look at it for angles. So I have 1 pair of angles, 2 pair of angles, 3 pairs of angles. So we have all 6 parts are congruent. So we can make the conclusion that triangle ABC is going to be congruent to triangle DEC. And again, the reason is because that's just the definition of congruent triangles, right? To be a congruent triangle, all 6 parts are congruent. All right, so it took a little time, but I thought it was worth going through. And I color-coded it, which was pretty sick. Okay. So let's do these. All right, so now we're given the triangle congruence statement, so we just need to look and identify the corresponding part. So segment RS is going to be congruent to segment LM. Make sure you're using the symbols. Segment LN would be congruent to RT. We could do angle S is congruent to angle M. We have TS, which is these two. TS would be NM. Angle L would be angle R. So it doesn't matter which direction we're going in from one triangle to the other. Angle N would be angle T. Okay. Now in this case, we're given that these two triangles are congruent. And now that they know that they're congruent, we can use that fact to find these missing things. So to find KL, well, KL, right, is corresponding. I'm going to look at KL as this. So it's going to be corresponding to GH. And GH is this right here. KL, GH is this right here. Okay, so that's fine. I don't know that one. Let's see if we can look at another one. Here's what we have to do. Okay, so yeah, we recognize that again. There's nothing to do here. Those are corresponding, fine. Okay, it doesn't help me directly solve for y, but I see y in another spot. I'm thinking, well, y is part of this. Now, I don't know anything about these two angles to make an equation out of, but what I do know is that JK, and I'm not kidding, is going to be the same as FG, right? So these have to be congruent. These are corresponding parts. So I do know that 3y minus 15 is going to be equal to 12. They're the same thing. So sort of 3y equals 27. So y equals 9. So now y is side KL. So KL does equal 9. Okay, so sort of I had to sort of do a little roundabout way. Now I got to find x. And so I recognize x is this angle right here. It's angle G. And so angle G corresponds to angle K. So it is 108. So basically I know that 4x minus 20 is going to be 108. So 4x equals 128. Right, which would be 32, I believe. X is 32. And am I done? Yes, I'm done because that's what I was looking for. Right, that's what I was looking for. Okay, pretty good. Let's do this proof now. All right, we have most of this filled out so we can look. This one, again, we have to remember our parallel lines, all that good stuff. We know that E is the midpoint of AC. Okay, so I'm just going to get an idea here. Which two triangles am I actually trying to prove congruent here? That's going to be, I'll look at that. So ABE is this triangle right here. Right, I'm trying to prove it congruent to CDE, because there are a lot of triangles in here. So we want to make sure we know which ones we're looking at. Okay, so now I got that taken care of. They already marked some of these things, but let's just start with what they gave us. They gave us that they're parallel, and they showed us that they're parallel, so that's given. Okay. We know. So now it's telling me based on the fact. Now I don't know anything else. It's not a given, so it has to be based on the fact that these are parallel. These things have to come that they're parallel. Fortunately, we know a lot of stuff about that. It's saying that angle ABE, which is ABE, is right here, is congruent to CDE. And that makes sense because if these lines are parallel and we have a line coming through here, this line BD, it's saying this angle is congruent to that angle. Oh, they're alternate interior angles. Okay, and we know that this is the same reason. So we can the other one is BAE. And so we know that BAE and DCE is what it gave me. So I'm going to mark them and say, oh, those are kind of the same thing, except it's just another transversal. So again, if they say the lines are parallel, we're sort of thinking transversals, alternate interior angles corresponding, whatever. In this case, they're both alternate interior angles. What I'm going to say is if the lines are parallel, then we know that alternate interior angles are congruent. All right, and then we have AB is congruent to CD. That actually is given right there. Bam. And then E is the midpoint of AC and BD. That also is given. But the fact that we're using, the next one says definition of midpoint, so we're using the fact that it is the midpoint. So let's look. So it says E is the midpoint of of both AC and DB. So if it's the midpoint, it's cutting this in half. So we know that AE is congruent to EC. Okay, so I can say that as one of my steps, that AE is congruent to EC. And also, right, I can actually say the same thing, because if E is the midpoint also of DB, I can say, well, then it's cutting this line in half as well, cutting DB in half. So I know that, also that DE is going to be congruent to EB. And those are both definition of midpoint. And then finally, we can say angle AEB, which is this angle here, is congruent to angle CED, which is this angle here. We actually kind of have our pick of reasons. We could say third angles theorem because we know the other two angles. We could say VAT, which is a personal favorite of mine. So we could say, you know, vertical angles are congruent. Congruent. And again, this is also could be, you know, third angles theorem as well. So sort of take your pick, but they are congruent. Perfect. All right, and then now actually let's check. We actually have all the stuff that I think that we need, right? We have angle, another angle, and a third angle, right? So we have three angles here. We have a side, and then a side here, and a side here. So we have three sides, three angles. Yep, that's enough to conclude that, you know, this is true. And so we know that this is just a definition of what congruent triangles are. All right, killing it, color-coded, all that good stuff. All right, back to this. This is a little more straightforward, right? We're just looking at polygon in this case. So segment DE would be congruent to segment LM. So we can write that in. I'm going to use it. Is this a normal pen? Yeah, good. LM. KN is first and last, so it would be first and last CF. Angle F is the last one here, so it's going to be angle N, last one over there. Angle L is the second one here, so it's going to be the second one there, angle D. So you can see how they're corresponding. It's all based, I don't have to draw a diagram, it's all based on that statement. Okay, we have some congruent triangles. We're given AB is 2x minus 10, and we're given DE is x minus 20. So what do I know about AB and DE? They're congruent, therefore their measures are equal, right? So their measures are going to be equal to each other. So I can actually say, okay, well, that means the measure, you know, basically it's saying that I know that AB is going to be equal to DE, and then we know their values. So I can just say, okay, well, AB was 2x minus 10, and DB is x plus 20. So we end up with x equals 30. So x equals 30. Are we done? Not quite, because we did find this part, which is 30. We're looking for AB, so we plug it back in, and we do 2 times 30 minus 10. We get 60 minus 10, which is 50, right? So we know that AB is 50. All right. So these are the parts here. Nice. All right. A couple more. All right, determine whether the angles are corresponding angles, corresponding sides, or neither. So LK and WY. Yeah, those are corresponding sides. So I'm just going to write chorus sides. All right. JL is 3 hash marks, or tick marks, I should say. And YX, and that's 2. So that's neither. XY, yeah, neither. Angle J and angle X, yeah, those are corresponding angles. Corresponding angles. Angle J and angle W, those are corresponding angles as well. And you can tell sort of by the tick marks, they're either, if they're congruent, then they're going to be corresponding in this case. So those would be corresponding angles. Angle K and angle Y, those are corresponding angles. And then W, X, and L, J, those are corresponding sides. LJ, WX, yeah. Just double check that one that I got neither. It was J, L, and YX. Yep, that's definitely neither. All right. Mark, it says down here we want to mark, based on this statement, we want to do all the congruency marks. So turn this down below on this diagram. We want to mark all these congruent. So I know angle L is going to be congruent to angle P. Angle M is going to be congruent to angle Q. I'll just use 2 for each of those. Angle N, so I'll use 3 now, is congruent to angle R. Zip, zip, zip. And then we could do the sides as well. So we can, switch to red for sides for fun. We can say LM, right, would be congruent to PQ. I'm just looking at the diagram. LM, right, first 2, PQ. We could do this last 2. MN, Minnesota, is going to be congruent to QR. Bam. And then finally, we get LN, which is first and last. 1, 2, 3 now will be congruent to PR. 1, 2, 3. Awesome. All right. complete the statement now. Angle R is congruent to angle N. Angle LMN, right? So basically that's just this angle, that's angle M essentially, would be congruent to angle Q, which we could just call it angle Q. And again, I'm all for making it simple. Of course, you could have like, also like P, Q, R. As long as Q is the vertex there, we should be good. LN, right, would be PR. And again, now that I have the diagram, I can look at either the diagram or this, right? But LN is PR, right? RQ would be NM. RPQ. I think the angle is a little easier to look at the diagram because RPQ is this angle, angle P, which is congruent to angle L. So I could say angle L, which I'll just do as one. M and L is this angle, which would be congruent to angle R. Again, you can put 3 if you want. Like angle R, of course, is just PRQ. Angle L is just MLN. The vertex is the middle one, though. So we can do it the same, but make it a little easier if we can, and why not? QP would be ML. And triangle PRQ, right, is going to be congruent to triangle LMN. No. PRQ would be P matches up with L. That's true. M matches up with Q. So it's R, I should say, is next. R matches up with N. So it's going to be P N M or L M N. So let's try that again. L N. No, I did it again. All right, we're going to back it up for a second. All right, N M. There we go. So I'll just erase that. But you guys will watch the video and know that I messed up big time. All right, but it's there. Arrows. All right. So now in this case, we are dealing with numbers, right? We're basically looking at one and figuring out. So DF, I'd say based on this congruency statement, DF matches up with AC. AC is 8, so DF will also be 8. Angle B is this angle. Angle B matches up with angle E, right? And angle E we know is 30, so it'll be 30 degrees. EF is this side. EF matches up with BC, and BC is going to be this side. So that's going to be 6. Angle C is going to be, it matches up with angle F, which is 90. The measure of angle A is going to be this one. It matches up with angle D. And so angle D, we could figure it out. We don't know it, but we can figure it out, right? We knew that B was 30. So either way, you want to figure it out. But again, we know that this is going to be 60 because they've got to add to 180, triangle sum situation. And so we know that this has to be 60. All right, let's see the next one, PZM and ATW. So AT is here, and AT I'm looking matches up with PZ. So PZ is 14. So AT has to be 14 as well. WA matches up with MP, so WA matches up with MP, so that has to be 10. WT matches up with MZ, which is 7, so this has to be 7. I'll mark them, because why not? Angle A is going to be matching up with angle P, which is 30. And I'm confirming on the diagrams, like angle A, right, is angle P. Okay, angle M would be angle W, and angle W is 100. And finally, we get angle, mark those. Finally, we get angle Z is congruent to angle T. It's corresponding and therefore congruent to angle T. We have to solve this, so we get 100, and we know that this is 30. So it's 130, so we know that this has to be 50 to get to 180. So angle Z has to be 50 as well. All right, and that is it. Great job, Mr. Spitzig. You're the best. I know. Thanks, everyone.